Hi, Victor. Nice to see you.
Good morning, Henry.
Or to hear you better. And apologies for not having sent around what we're going to discuss. I remembered your comment from last week too late.
I think yeah. So I actually reviewed the graph, what is called the graph database for. Yeah, I think it's very interesting. Yeah, I think if people know that there is actually something to discuss based on that, it will be more people who can.
Yeah, I agree as I agreed last time, but yeah, I thought of it too late, and so then it was a little bit, would not have made much sense.
Maybe while waiting, do you want to bring up that graph to maybe take a look? I'm sure people will be maybe watching the recording. Maybe we can go through that graph data, that tool to look into the thought process for how that categorized and all that.
Yeah. Okay, let me just set up my screen, and then I'm going to share this. So this is what you wanted to do, right? Basically show the graph and then, oops.
I feel that, I mean, a lot of threat modeling is not as systematic as you're doing. So, but if people understand really the power behind your taxonomy, I think more people will be interested in joining the discussion.
All right, I'm also completely open to not doing it in a very systematic way. Hi, Avishai.
Hi, Henrik. Nice to meet you.
Yeah, nice to meet you. Okay, so the little thing that I did since the last session is that basically I described all the remaining flows in those tables below, which was one of the suggestions of one of the previous attendees, Abdullah Garcia, right, who said it would make sense to describe all the reddish flows of third-party code from public distribution platforms to the different systems in the organization. That is the first table that you see a little bit below.
If you're talking, you're on mute, Henry.
Am I?
No, I hear you.
Yeah, no, thanks.
Sure.
Victor, then I think it's a problem on your end.
Oh, maybe on my, okay, maybe, yeah.
Yeah, so just to recap, both those reddish data flows, and maybe let me zoom a little bit, those reddish data flows from some distribution platforms to different elements in or systems in the development environment are described in this table. And just earlier today, this is the first table, and the second table basically shows and summarizes all the blue parts, which is the flow of proprietary code, basically from the brain of the developer to his workstation to the Git build systems up until the user on the very right-hand side of this high-level architecture. Yeah, Abdullah said it would make sense to document those data flows. It's a pity he cannot join. He pinged me earlier on that he's not available, but yeah, maybe he can provide some feedback on those and complement and offline or in the next edition. And so I think Victor and Avishai, yeah, maybe what we can do today is really go through the lists, concentrate on one of the systems, maybe the workstation, and come up with all the possible problems that result from the consumption of potentially malicious open source components on the workstation. Maybe it's even making sense to go through the list or just come up with a number of examples. And we already started, and maybe we can just continue here.
Yeah, I think that's a good idea. Maybe we can maybe using the workstation as a keyword to look through your taxonomy database to see which one applies to workstation and whether there's even anything that's not already part of that taxonomy database.
Yeah, I mean, I don't think there is really the word workstation also occurring in any of the descriptions. I mean, the idea of the text, the idea of the text. Yeah, go ahead, Victor.
Sorry, I don't mean the keyword workstation. So, for example, I gone through your the graph, the taxonomy database, right? So there yeah, just on the screen there's development, right? That's probably related to the developer workstation. And then the second, the second create name confusion package, would that be even related to the workstation?
That is definitely one thing that is related to the workstation. So create name confusion here. The idea is that attackers basically give names in one or another way similar to packages that are well known or that are commonly used. And so what the common example, and maybe let's just focus on this since you have picked this example. And one example is, of course, the typo squatting that all of us have heard about in the last couple of years. But then there are a couple of other comparable techniques, right? So I think there have been numerous cases where, for example, malicious actors, they were just prepending AWS dash in front of a package name just to make it look like it came from Amazon, right? And just kind of they establish trust, and let me just click on it. They establish trust into the package just by pretending it comes from AWS. This is, but I think the typical example of typo squatting and is where you have pip install or npm install, right? And so I can maybe write this down. It's the kind of manual.
By workstation, do you mean the workstation of the developer or the workstation of anyone, like user, hacker?
No. This is, so since all this model here is depicting the in-house development infrastructure of a large software development organization, all the blocks that you see here, so the workstation, the Git, the build system, the build, and so forth, these are all different systems within that development organization. And in particular here, the workstation is belonging to a software developer. I wouldn't want to, because we discussed those malicious open source consumption and open source packages in the context of developing software. So I wouldn't want to have to describe the workstation, of a guy working for the HR or legal department in a company. This is not so interesting, I find.
Oh, okay. Now it makes sense. So this is an example of large-scale in-house development.
Exactly. So,
Henrik, I would urge you not to use the word workstation, because there is an actual technical definition of what a workstation is. Like, there are like actual physical workstations that like some people are issued. Like if you work in creative, like you have they have specific graphic cards for workstations that allow you to render a bunch of stuff. So there is a specific technical definition of workstation. So I would urge maybe our wording there might be better. Like it's not just a workstation, but it could be any computer you're doing development on can be considered, a workstation.
Yeah. Okay. All right. So a little bit below, I named it organization internal development environment. I'm not sure whether this is making it much better, but
yeah.
I take the comment and try to retrofit this somehow, right?
I actually think the technical definition would be like end terminal, but no one would understand what that would mean. So
yeah, I mean, a short and concise name would be appreciated. Yeah, and indeed, later on, I clarify also that, I mean, if you log on to a virtual machine hosted by your company, and that is what you use for developing, that would also qualify kind of as
maybe just developer
development.
machine.
Yeah.
That might just be the best way. That way you cover virtual, you know, laptop, workstation, container.
Yeah. Yeah, no, I agree. That sounds better. Yeah. I will change this later on throughout the document and maybe the
Thank you.
The charts. All right. So coming back to this name confusion attacks. So I think the typical example we know from the blog posts and so forth would be pip install or npm install. But I think the same holds true for kind of marketplaces where you have kind of you have a drag and drop, or you install by means of buttons. So of course attackers can create such name confusion also in other marketplaces. This is not restricted to these command line package managers, let's say. And I'm not sure whether the attacks, there were some malicious Visual Studio Code plugins found in the wild a couple of months ago. I'm not sure which of those, if any of those techniques they were using. Does anybody remember?
I can check if
because I don't have the names on the top of my head. And so I would like to, I think it makes sense to make this explicit that kind of this is through package managers.
Is that brand jacking stuff that you have on your other screen?
I'm not sure which technique was used. I mean, brand checking and typo squatting and combo squatting, these are just alternatives on how you manipulate a name, a legitimate name, in order to trick users into installing it. I'm not sure which of those confusion techniques was used for this Visual Studio Code plugins. It would be nice, in fact, I think, to have examples for the different threads here when they materialized.
Yeah, I like that developer machine. Easier to understand.
Mm-hmm. Yeah. Okay, so those name confusion attacks, I think, are primarily relevant here for this developer machine. But I guess we will also see them at later points in time. So because in a comparable way, if you have kind of, for example, an in-house GitHub Enterprise installation, if I'm not mistaken, you can also install applications and extensions or modules on that. And in the same way, again, if you have a Jenkins installed internally in your environment, you can again install whatever plugins are available on the Jenkins marketplace. So I guess we will see this name confusion attacks at different points in time, only that that it will be about different packages and kinds of software.
If I may, Henrik, one thing I would want to point out, I think like with your first point, I don't think that is, I mean, that is correct, but as a packager, I can tell you that that statement might not be taken with the best light in the packaging communities, because what the packaging communities would tell you is that there's a reason that we offer everything openly, because you should verify before installing anything. We're not a community where no package community, as far as end user packages, will actually ensure security. As Homebrew likes to say, they like to say it in the sense of like it's just not our purview. We're a last line of defense. So I would recommend maybe there you reword that as far as blaming it on a misconfiguration. You should definitely like verify things before you install them. At least I could tell you from Portage and Homebrew, which are the two communities I'm a part of, that both of them would agree with you there, that like what we offer is simplicity, but it's not like an end all be all. You should definitely be familiar with what you're installing.
I understand what you mean, but I think what you say is rather a safeguard or a countermeasure, right? So what we described first are, these are the problems, these are the things that can go wrong. And then later on, we come to what you should do differently and what we can do about it, right? And so I agree, you should only install and verify before you install anything. But for me, this is something that comes at a later point because it is a control. Since we didn't go over those, this is, I think, 2 bullet items that we have created like 2 weeks ago or so. I can maybe say a sentence about this. This is something that basically, if you have a package manager like Maven or Pip, in bigger corporations, they should be configured to download open source as well as internal packages from an internal trusted binary registry like JFrog or Sonatype, right? But because this is where all the open source packages that are hopefully vetted or at least mirrored end up. And so what I mean, or what we meant with misconfigured package managers, is if developers do not configure their local system accordingly so that it is pulling stuff directly from the internet rather than from the vetted registry. I'm not sure.
I agree with what you're saying, but I would also argue that you should still, like, I personally think that no matter what you do, you should verify before installing anything. That's just being a smart user. So because there have been situations where that doesn't always work, or where the link gets hijacked. So I'm just saying that, like, I get the intention. I just think that it should be clarified that, like, there's also an oversight there where you're not verifying before installing, which in and of itself is a problem, is what I'm trying to say.
How would you phrase this?
Yeah, exactly. The way that we say it in the community, that you should always verify it before installing. This is where, like, that, like in the community, we say trust but verify always. That's kind of the saying. So don't install anything without verifying. And if you skip that step, you're already down a path of hurt, if that makes sense. This is beyond the fact that, oh, well, my package manager gave me the wrong package or anything. Like, you should have probably at least pulled up the recipe and made sure that's the right package, because sometimes there are packages with similar names.
So right now, how to verify? I'm not a big developer of security, so like nowadays, my understanding is to verify in like SBOM, bill of material is the best way. So with Brew and NPM or this package installers, how do you is SBOM going to be integrated? If not, how to verify?
That's a very good question. I think everyone has their own version of how to answer that question, because like NPM would answer with package lock probably as part of their answer. With Portage, they would probably answer that is just shell scripts. So if you know shell scripting, you should be able to like understand what's going on, and further on, it should be fairly easy to modify if you know some simple bash scripting. Now, Brew has their own DSL. It's pretty straightforward. The easiest way to verify with Brew is via the SHA-256, which is what they use to basically check some all packages. And I actually built an AI that verifies all of this information before it actually gets uploaded to Homebrew and Homebrew Cask. So that's what I'm saying, that like there have been problems in the past, for example, with packages, especially like on the Homebrew Cask side, where there have been applications that have been bought by other companies with nefarious intent that start installing spyware and stuff like that. And then it becomes an issue because users say, why did you install this on my computer? And it's like, because we don't carry an opinion on what you install. You should know what you're installing. We basically just carry it, and it passed our verification checks because what we verify is that it actually came from the vendor, and it legitimately came from the vendor. But what happens when the vendor becomes toxic itself? And the vendor's just pushing out bad updates that are completely valid, because as a package, it's completely valid, but it's just the vendor went and got bought out by some spyware company.
So I think there should be, so the one part of the verification is just to check the integrity of the binary you have downloaded, right? Is it what you install really what is hosted and what has been published by the respective publisher? And the other part, which goes well beyond that, and I think you mentioned this in regards to shell script, is really looking at the code and trying to understand what it does, which is of course only possible for very small dependencies.
And that's actually to be honest with you, Henrik, that's actually always been the big discussion, because kind of the whole part of open source was like, okay, well, you should do this with all open source, that you should verify it before you install it, make sure it meets your needs. If not, you can modify it, customize it, whatever. But yeah, like a lot of people, that's just not possible. And that's one of, like, for example, you look at WireGuard, and that's one of the selling points of WireGuard, that you could sit down and audit it in an afternoon. You could read the whole thing and understand what it does. When you go to like Open VPN, you can't do that in an afternoon. It's taken people months to understand half of what it does. So that's always been an argument, like that like, this is great in concept, but in application, does it really work? And I could tell you firsthand that yes, I've seen people make it work, but I have also seen a lot of people struggle with it. But there are parts of it that I agree with, and I do agree with the fact that don't be installing stuff just because I've seen a lot of things. I've seen vendors go, oh wait, let me just update this package really quick. Nobody will notice. People notice, and it could definitely throw things off. So I would definitely say, like, before you install anything, make sure you know what you're installing, even if that is pulling up, like, I'm sure Maven, I don't work as much in Maven, but I'm sure Maven has it, and most package managers have them. And you can at least figure out what binary where it's coming from, and if at least it passes the sniff test, because basically that's what your package manager will do, is just verify that it came from the vendor. And sometimes it very legitimately comes from the vendor. It's just the vendor became toxic.
I think where we will see a difference also is, I mean, here we speak of this development organization that is not in a highly regulated environment. So I guess the verification steps and the concrete activities performed differ on kind of your risk appetite and whether you're subject to regulations or not.
True.
All right, so and this can be anything from a sniff test, looking up how many stars the project has, up until using whatever SAST and DUST tools on those. Just take some notes in order to not forget. Feel free to jump in and suggest further.
Absolutely.
If you find this in.
I just found a link about SBOM and NPM. I'm not sure. Is it going forward? Is it the direction that all packages, including Brew NPM, is going to all use SBOM?
SBOM is a very highly polarized topic in the actual community at large. Like for us as security people, it's a solution, but I don't know, and I can't tell you that. I could tell you that, like, I'm a part of a lot of conversations in the greater community, and I could tell you that, like, no, it's not something, it's not as unifying as you would think inside of the communities, because Homebrew, for example, I could tell you their position firsthand is that they're not going to implement it unless OpenSSF is willing to invest like the money, effort, time, energy that it would cost them, which is a lot of money, because for example, we've talked to them about it, and yeah, it just, I don't foresee that happening at any point in the future. And that, if that's not going to fly for Homebrew, like, it's not even worth talking about Portage. And that's the other thing, Victor. If you really want to know where that conversation goes down a path that OpenSSF is really insensitive to the fact that security has existed long before OpenSSF was ever a thing. And there are multiple generations of security, and that different people have implemented this security in different ways. And now you coming here with SBOM and your newest shiny toy doesn't really solve anything, because I already solved that problem. And if you don't like it, then that's not my problem. That's how most communities react, if you want an honest truth.
Yeah, I always prefer the honest truth. And
so it's an uphill battle for sure, is what I'm saying.
It's good to know the truth.
All right, good. So, and I think we remain stuck at the first one, right? So maybe another sentence of the second. The second was basically, even if you have maybe an approval process within such an organization that controls what developers are supposed to install on the developers, one possibility, of course, is that they just completely ignore it and install it from other sources directly, basically bypassing any approval processes. Right, the name confusion attack.
The other thing, let me also say this, Hendrik, you have environments like Node that have multiple like package managers. So it really might not even matter if you have something installed, because if somebody decides to just use PMPM instead of NPM, I mean, there's ways of bypassing it that way.
So then what you say is that basically there are so many kind of package managers or alternatives for fetching packages that it is hard to make sure that those approval processes, all those configurations are enforced in all the different ways you can download stuff.
I would say that it highly depends on the ecosystem that you're a part of and what that ecosystem offers, and making sure that your developers stay within, if you want to call it that ecosystem, even though in NPM world that wouldn't be correct, because NPM has like Yarn, NPM, and PMPM. And then you have things like Dino, and you see, like, even with me and like at SKF, we have issues like that where developers are like, hey, you know, like, I built this and I built it in Dino because I thought Dino is cooler than Node. And yeah, you know, like, it's so I would say that, like, you know, definitely staying within, like, understanding where you're working and using the tools correctly, because, like, for example, NPM is very powerful if you want to make sure, or you want to maintain that integrity of your code base. Like, they do offer a lot of tools, but this is where, like, at Apple, we used to say we have to make security transparent, because if you make security too complicated, then your employees will actively work against you to, like, bypass your security. So I would say that understanding, like, the tool that your company is using, and make sure you're using that tool. And there's a lot, this conversation can go on and on and on, right? Because there's a lot of different tools. There's a lot of ways of accomplishing this. Environments, dev containers. A lot of people are trying to fix this problem. But I would definitely say whatever your company is using, definitely stick to that. My suggestion.
Okay, so then I just try to formulate this in a thread. So the problem is maybe that organizations do not come up with a defined set of tools in the first place, or even if they come up with a defined set of tools, the developers, for whatever fancy reason, prefer Dino over NPM or God knows what.
Correct.
Okay.
So I would say that it's important to develop maybe like a tooling or a tool set that works with everyone. Everyone understands.
Okay, so I kind of said it like this: lack of a defined tool set to be used by developers, and this lack results in developers using whatever they feel is most appropriate.
Mm-hmm.
All right. Okay, now that is, and so here then the second one is kind of slightly different in the sense that maybe they use the package manager they're supposed to use, but they don't configure it properly.
Right.
And this is all right. Good, very nice.
So how does the third one differ? Bypass of approval processes. So one is lack of, and one is there is one, but
I think 1 and 3 are kind of very similar.
Yeah. Oops. Yeah, for me, I mean, I think when we were writing this down, we rather thought of, these are the I feel for tools are very often extensible, right?
Mm-hmm.
And so even if you say you're going to develop with Visual Studio Code, and then you're going to develop with, I don't know, NPM or so, then you need to further constrain what can be installed in this context. What are the plugins allowed or not allowed? But I agree, there is a little bit of an overlap here. I don't know how to iron this out.
Unfortunately, Hendrik and team, I have to jump off because I have another meeting at LF, but I will be back next week and I will take a look and I'll add some notes in.
All right, thanks. Thank you so much
for
joining. That was very useful. Have a nice afternoon.
I'll talk to you guys later. Bye.
Bye. I'm just, it's any immediate ideas how to iron this out, or shall we proceed and I make an attempt following the session? I guess this means the latter. All right, so how else can potentially malicious open source components end up on a developer's machine? All right, so here maybe, and this is indeed following a little bit the different flows. I think so far we have mostly discussed data flow 1, where the developer for one or the other reason is just installing wrong stuff. I think this one here, this data flow 2, where stuff is downloaded from a private repository, this gives rise to a problem where maybe things that have been mirrored and maybe have been vetted and so are available in this private repository, they can be also altered once they have been mirrored. And so basically there would be the download or kind of download of tempered artifacts from internal repository.
So this is a malicious insider kind of a scenario? I mean, how was it tempered after it was?
Yeah, true. Right. Yeah, true. This is what we excluded, right? Indeed, this would be
exactly.
this would be the insider threat.
Unless I'm missing something, right?
Yeah, no, yeah. I just tried to see whether there's any other way of. Is there any way of an external achieving this in some way?
So maybe the mirroring or the vetting of mirrored content isn't perfect, and then it was downloaded already tempered, and you are getting it also internally. Does that fit your scenario?
Right. So this would be something that is kind of affecting this data flow number 5, right? So maybe this would be. Yeah. Basically, insufficient or incomplete vetting processes, right? You just do a superficial review, which is not deep enough. All right. So then I basically delete this. This would also affect the and I think so this would be download of. So now we're talking about a different system, but doesn't matter so much in my eyes. Or insufficient. And the other one is this what, does it describe what you meant?
Yeah. Thanks.
Or I wonder, maybe they do have a very great vetting process. They look at it at all different angles, but then they take the wrong artifact that they mirror. So let's say they vet, I don't know, package foo version 1.1, but they don't without actually saying where they get it from and what would be the digest. And so the mirror process, which is technically maybe some independent process, just downloads this version foo 1.5 from somewhere else. And so they have vetted the wrong thing, basically.
Yeah, makes sense.
Does it make sense?
Yeah.
Okay. So what are any other possible ways to have some malicious open source component on your developer workstation or machine?
For me, it will be all going back to that taxonomy database to look at other possibilities.
Yeah. All right. So if we start from the top. So they develop and advertise distinct malicious package from scratch. Here, the idea was, it's actually quite a high effort compared to this name confusion attack, is that an open source project is set up from scratch with some useful functionality. The people make some effort to advertise it. It is adopted, and the malicious behavior is only added at a later point in time, right? So it is fine and legitimate for quite some time, and then it is turned. And so I guess this is something that also applies. And maybe here I just write the different identifiers so we know where those are coming from. So this were here, the AV200 was all that. So actually projects. Or turn malicious. So I think this is, and just coming back to this review processes. And so I think it depends a little bit. So I'm not sure how typically the vetting process, if any, is existing. It should look, the question is, what does it look at, right? Does it look at just every patch, or every minor version, or every major version? And so I guess here the threat is that the vetting process, if it is in place, is just looking at a subset of the versions. And so such a malicious package can of course inject the malicious behavior also at any other point in time. All right. Anything else on that point?
Just a bit unclear about the hierarchy of the points we are.
Yeah.
You understand where I'm going? Because some of it seems like it should be. Like,
it should be rather on the top, right? We were speaking of these vetting processes above, exactly. And now I put it here again. Yeah. Exactly. True. Yeah, I kind of agree. Okay, well, we can also try to move this here. Yeah, I have the feeling it's always tricky. I have the feeling we talk again, since we focus so much on the vetting process, we kind of speak about the process, about the control, about a safeguard again. But yeah, let me see whether we have collected some examples here. Yeah, that one is an interesting. Here, star jacking. I don't know whether you remember. So this is basically a technique that would be used to set up such a apparently useful package, right? So you can basically, I think it was an npm. I'm not sure whether they changed this, so that you could, for whatever package you have created, I think you can reference other GitHub repositories, and so you would basically get the stars and the fork count of that GitHub repository, even though your source code of what you have deployed doesn't relate to that GitHub. So this is a technique for kind of promoting such packages, maybe. Yeah, I don't know. Can't remember this here. Okay, yeah, I don't have anything else. Victor, you have any other idea on this?
Sorry, I didn't was talking. What's?
I'm just kind of thinking whether there's anything about this first thing where we have this develop and advertise distinct malicious package from scratch, whether there's anything else to note down, and how this could end up on a developer machine.
Yeah, my understanding is, of course, using those packages, getting directly from GitHub, or maybe the developer can copy and paste, basically borrow that open source code directly into a code on the developer machine.
So you mean he would take open source code and copy paste it into the repositories of his company, basically?
Yeah, instead of using a package installer or the downloading from GitHub, he could be developing something and say, okay, cool, I'm gonna write something, a Java application. So I'm gonna go to a website, copy part of that Java code into his own code on the developer machine.
Okay, so this would be all right. Okay, so I see. So let's say the attacker sets up a lot of useful resources for explaining how to develop a Spring application that is meant to be used as a template, for example, and which is supposed to be copied as is into a homemade thing. And so you would, so this is what you mean, or maybe you have some malicious code on Stack Overflow that the people copy and paste over.
Even someone not intentionally just write some sample code in a blog, say, okay, you can do this, which have a memory bug, and then developer just, okay, cool, I'm gonna just copy this part into my code and use it.
Yeah, I like that. That's a nice way. for spreading malicious code. But the thing is maybe a little bit, it will be difficult, I guess, for the attacker to know where his deliberately vulnerable code ends up. But yeah, still, I completely buy this. Yeah, I guess this is part of AV100, and so. So attacker sets up or shares, provides malicious. Right? Does it capture what you were saying?
Yeah, but as I said, maybe it's not even attacker. It's just unintentionally. I don't know how you call that attacker. It's just someone, the developer basically use a code that's not good. Basically, not necessarily from an attacker.
Yeah, but so I agree. This is definitely a problem, and I think there are numerous articles recently about whether those GPT models produce vulnerable or non-vulnerable code. But I think here we, if I'm not mistaken, we wanted to really focus on really on attacks, not on kind of accidental vulnerabilities being introduced or shared or otherwise spread. Even though I must.
That's actually a good example. If I say, if I talk to ChatGPT or what is called the Google one, I say, can you write me a code to how to interface to ChatGPT version 4? Right, write me a code, and then it just run. It will run, create an example code that have a weakness there, and then because it's ChatGPT, it probably reuse that code everywhere, and that become a weakness that attacker can be aware of. Then so even if it's not coming from the attacker itself didn't install that weakness into the. It is available everywhere for him to attack.
There was a nice blog post just the other week, I think beginning of May or so, where some malware researchers, security researchers were looking at malicious Python packages, and they looked at some of the functions of the malicious code, and then they basically asked OpenAI or ChatGPT to produce a function that is performing the respective feature, maybe taking screenshots or so. And it turned out what they found in this malicious Python package had really the same structure and in part was identical to what ChatGPT produced. And so they basically inferred that the malware authors also heavily rely on ChatGPT in order to build the malicious code that they distribute on PyPI and NPM, which was a funny, interesting observation.
Yeah, the attacker could feed the ChatGPT with ChatGPT and is basically looking for examples on the internet, right? So they can feed that with the wrong information. So ChatGPT can be attacked that way. And also the use of machine learning is also interesting because machine learning is just an algorithm, right? It's backpropagation and all that. So it can be used for protection, but at the same time, it can be used to install wrong information as attack.
Okay, that is a nice one. I like this. Basically,
actually
share
the education SIG that is part of the best practices working group one of the goals is to identify sources of insecure code snippets. For instance, in Stack Overflow, as you just mentioned. I just pasted the link to it.
Cool. I mean, this will be very useful. And this is, I think, part of why we do the whole exercise is linking all the different activities. So that is a very good thing to do here. Oops. I didn't want to open it. I just wanted to copy the link.
Because one thing I find interesting is I was actually looking for some interesting information about a particular professor. Actually, I was looking at the ChatGPT and the Google one. ChatGPT didn't give any answer. Google did. So it looks like Google probably did some internet crawling and find that information where ChatGPT did not. So that it really depends on to be able to answer those questions, it got to read that information from somewhere.
Yeah. No, I used it in the past for performing malware assessments, and that worked pretty well as well. So I basically extracted code snippet from malicious packages and asked whether it should describe the behavior and come up with a risk score, whether it's malicious or not. And that worked pretty good, I must say. At least in the later versions. All right. Good. Other sources of malicious code ending up on the developer machine.
I'm not sure. I think your technology already covers this, I believe, but other like email is very common, right? Download.
Okay, so here would be, all right. Okay, but this would be, okay, this would be a bypass or so of one of those, right? So you do have an established way to obtain packages, and rather than using this, you download and install software that you receive by email. I would think this is
yeah,
covered.
Someone says, can you, for example, sometimes I did it before. Like I cannot what is called the secure shell client is not working. So I talk to my colleague, say, can you send me one? And send me your version. Then he's gonna send me through email. I just download it and use it.
Okay, so then is this covered? So here we have this is more about approval processes, versions, package manager configuration. Okay, so then you say it's basically use of non-approved or non-approved distribution channels. Again, I have the feeling it's a little bit overlap again. I think I need to define this a little bit better.
Yeah, I think it's already covered by your other points, but yeah, it's just one example, I guess.
Sorry, I got to move on.
Yeah, what time is it? Oh, we have 4 o'clock already. All right, but that I like this very much. Thank you so much for the discussion. I try to write it up and structure it, and hope to see you next week.
Yeah, thank you for it's interesting to learn. Thank you.
Thank you. Bye-bye.